Hello children, good morning. In the earlier classes, you have learnt about polynomials in one variable, degrees of polynomials and zeros of polynomials. This year, you will study about polynomials in two variables, relationship between the zeros and coefficients of a polynomial, and geometrical representation of linear and quadratic polynomials. Now, let us recall a few concepts which you have studied in 9th standard. So, what is a polynomial? You know, an expression of the form p of x is equal to an x to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 so on, where an is not equal to 0 is called a polynomial in x, polynomial in variable x of degree n. Here a0, a1, a2, a3, an are real numbers and n is a non-negative integer. N is a non-negative integer. You know, the highest power of the variable is called the degree of the polynomial. Here, in the polynomial p of x, n is the highest power. So, the degree of the polynomial is n. Example, 3x minus 5 is a polynomial in the variable x of degree 1. Y square minus 3y plus 2 is a polynomial in the variable y of degree 2. Next, types of polynomials. Depending upon the degrees of polynomials, we can classify the polynomials into 4 types. Linear polynomial, quadratic polynomial, cubic polynomial and biquadratic polynomial. Then, what is a linear polynomial? A polynomial of degree 1 is called linear polynomial. A polynomial of degree 1 is called a linear polynomial. The general form of a linear polynomial is p of x is equal to ax plus b, where a is not equal to 0. Example, 2x plus 3 and root 5y minus 2. Here, in the polynomial 2x plus 3, the degree of the polynomial is 1. So, it is a linear polynomial. In the polynomial root 5y minus 2, the degree of the polynomial is 1. So, it is a linear polynomial. Next one is quadratic polynomial. A polynomial of degree 2. A polynomial of degree 2 is called a quadratic polynomial. The general form of the quadratic polynomial is p of x is equal to ax squared plus bx plus c, where a is not equal to 0. Example, 2x squared plus 5x minus 1 is a quadratic polynomial in variable x, and p squared minus 3p plus 5 is a quadratic polynomial in variable p. So, a polynomial of degree 1 is called a linear polynomial, and the general form of the linear polynomial is ax plus b, where a is not equal to 0. And a polynomial of degree 2 is called a quadratic polynomial, and the general form of a quadratic polynomial is ax squared plus bx plus c, where a is not equal to 0. And the next one is cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. A polynomial of degree 3 is called a cubic polynomial, and the general form of a cubic polynomial is p of x is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0. So a polynomial of degree 3 is called a cubic polynomial, and the general form of cubic polynomial is ax cube plus bx square plus cx plus d. Example: 3x cube plus 2x square plus x minus 1 is a cubic polynomial in the variable x, and 2m cube minus m square plus 10 is a cubic polynomial in the variable m. Next one is biquadratic polynomial. A polynomial of degree 4. A polynomial of degree 4 is called biquadratic polynomial. The general form of biquadratic polynomial is p of x is equal to ax to the power of 4 plus bx cube plus cx square plus dx plus e, where a is not equal to 0. Example: a to the power of 4 minus 5a cube plus 1 is an example of a biquadratic polynomial in variable a. Then y to the power of 4 plus 2y cube minus 3y plus 10 is an example of a biquadratic polynomial in the variable y. Next one is value of a polynomial. Let a be any real number. Let a be any real number. If you substitute x is equal to a in the polynomial p of x, then the value obtained is called value of the polynomial, and is denoted by p of a. Example: consider a polynomial p of x is equal to 2x square minus 3x plus 5. Substitute x is equal to 2 in the polynomial p of x, then p of 2 is equal to 2 into 2 square minus 3 into 2 plus 5. So 2 square is 4, 4 2s are 8, minus 6 plus 5. So 8 plus 5 is 13, 13 minus 6 is 7. So the value of the polynomial at x is equal to 2 is 7. Next, zeros of a polynomial. Let a be any real number. If you substitute x is equal to a in the polynomial p of x, then if the value of the polynomial p of a is equal to 0, then a is called 0 of the polynomial 0 of the polynomial p of x. Example, consider a polynomial p of x is equal to x squared minus 2x minus 3. If x is equal to 3, then p of 3 is equal to 3 square minus 2 into 3 minus 3. 9 minus 6 minus 3. So 9 minus 6 minus 3 is minus 9. 9 minus 9 is 0. Here the value of p of 3 is equal to 0. So 3 is a 0 of the polynomial. So 3 is a 0 of polynomial p of x is equal to x squared minus 2x minus 3. So if the value of the polynomial is 0, then the real number is called 0 of the polynomial p of x. Next is relation between the zeros and coefficients of a quadratic polynomial. Let alpha and beta be the zeros of a quadratic polynomial p of x is equal to ax squared plus bx plus c, where a is not equal to 0. If alpha and beta are the zeros of the polynomial, then x minus alpha and x minus beta are the factors of the polynomial p of x. Therefore, we can write p of x is equal to ax square plus bx plus c. Ax square plus bx plus c is the standard form of a quadratic polynomial. Since x minus alpha and x minus beta are the factors of the polynomial, we can write k into x minus alpha into x minus beta. Here k is a constant. K is a constant. So next, k into the product of x minus alpha into x minus beta is x square minus alpha plus beta into x plus alpha beta. Next, multiply by k, kx square minus k into alpha plus beta into x plus k alpha beta. Now, compare the coefficients of x square, x and the constant on both the sides. Now, on comparing the coefficients of x square, x and constant on both the sides, we get k is equal to a. So k and a are the coefficients of x square, and the coefficients of x is minus k into alpha plus beta. Here the coefficient of x is b, and then constant is k alpha beta is equal to c. Now here the k is equal to a. So substitute a in place of k. Minus k into alpha plus beta is equal to b. So alpha plus beta is equal to minus b by a. And here also substitute a in place of k. A alpha beta is equal to c. So alpha beta is equal to c by a. So alpha and beta are the zeros of the quadratic polynomial p of x. So the sum of the zeros of the polynomial is equal to minus b by a. Here b is the coefficient of x and a is the coefficient of x square. So the sum of the zeros of the polynomial is minus b by a. And the product of the zeros of a quadratic polynomial is c by a. Here c is the constant and a is the coefficient of x square. And therefore, if alpha and beta are the zeros of a quadratic polynomial, p of x is equal to ax square plus bx plus c, where a is not equal to 0, then the sum of the zeros alpha plus beta is equal to minus b by a, and the product of the zeros alpha beta is equal to c by a. And a quadratic polynomial whose zeros are alpha and beta is given by p of x is equal to x square minus alpha plus beta into x plus alpha beta. It means x square minus sum of the zeros into x plus the product of zeros. Next, relationship between the zeros and the coefficients of a cubic polynomial. Let alpha, beta and gamma be the zeros of the cubic polynomial p of x is equal to ax cube plus bx squared plus cx plus d, where a is not equal to 0. If alpha, beta and gamma are the zeros of the cubic polynomial, then x minus alpha, x minus beta and x minus gamma are the factors of the cubic polynomial. Therefore, we can write the cubic polynomial p of x is equal to ax cube plus bx squared plus cx plus d is equal to k into x minus alpha, x minus beta into x minus gamma, where k is a constant. Next, k is equal to multiply x minus alpha, x minus beta into x minus gamma. If you multiply x minus alpha, x minus beta and x minus gamma, you will get x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. Next, multiply each term by k. Kx cube minus k into alpha plus beta plus gamma into x square plus k into alpha beta plus beta gamma plus gamma alpha minus k alpha beta gamma. Now, compare the coefficients of x cube, x square, x and the constant on both the sides. Next, by comparing the coefficient of x cube, x square, x and constant on both the sides, we get k is equal to a, and minus k into alpha plus beta plus gamma is equal to b, and k into alpha beta plus beta gamma plus gamma alpha is equal to c, and constant minus k alpha beta gamma is equal to d. Here k is equal to a. Substitute a in place of k. Minus a into alpha plus beta plus gamma is equal to b. So alpha plus beta plus gamma is equal to minus b by a. Here again substitute a in place of k. A into alpha beta plus beta gamma plus gamma alpha is equal to c. Next, alpha beta plus beta gamma plus gamma alpha is equal to c by a. And here minus a alpha beta gamma is equal to d. So alpha beta gamma is equal to minus d by a. Therefore, if alpha, beta and gamma are the zeros of a cubic polynomial, then alpha plus beta plus gamma is equal to minus b by a, and alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. And a cubic polynomial whose zeros are alpha, beta and gamma is given by p of x is equal to x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. So this is the general form of a cubic polynomial. Now, let us know about the geometrical meaning of the zeros of a polynomial. If we plot the linear polynomial on the graph of the linear polynomial is a straight line, and the straight line intersect the x-axis at exactly one point, so the linear polynomial has only one zero. Next, the graph of a quadratic polynomial is a parabola. It intersects the x-axis exactly at 2 points, so the quadratic polynomial has two zeros. The next is cubic polynomial. The graph of the cubic polynomial intersects the x-axis at most 3 points, so the cubic polynomial has 3 zeros. Now you know the graph of a linear polynomial intersects the x-axis exactly at one point, so the linear polynomial has only one zero. And the graph of a quadratic polynomial intersects the x-axis at most 2 points, so the quadratic polynomial has two zeros. And the graph of a cubic polynomial intersects the x-axis at most 3 points, so the cubic polynomial has 3 zeros. So in general, the graph of a polynomial of degree n intersect the x-axis at n points. Therefore, a polynomial of degree n has n zeros. Therefore, the zeros of a polynomial are the x-coordinates of the points where the graph intersects the x-axis.